Welcome to KODY channel. Today we are going to discuss magnetism and electromagnetism part 2. The part 1 I will keep in the description. I will keep the link in description. I will thank you to everyone who support my channel, and it is helpful to the people who are preparing for the competitive exams while doing their works. Before going to the topic, please subscribe my channel. Hit the notification button. You will get a notification when I update my videos, and like and share this video to your friends. Let's go to the topic. Gilbert is a unit of, you can see that Gilbert is a unit of electromagnetic force, magnetic force, conductance, permittivity. The Gilbert is a unit of magnetomotive force. The use of permanent magnets is not made up of. The use of permanent magnets is not made in magnetos, energy meters, transformers, and loudspeakers. In transformers, we not use these permanent magnets. Supermagnetic materials are composed of ferromagnetic particles in ferromagnetic matrix, non-ferromagnetic particles in ferromagnetic matrix, ferromagnetic particles in non-ferromagnetic matrix. Supermagnet materials are composed of ferromagnetic particles in non-ferromagnetic material. Susceptibility is positive for non-magnetic substance, diamagnetic substance, ferromagnetic substance, none of the above. Susceptibility is a positive for the ferromagnetic substance. One Maxwell is equal to 10 raised to minus 8 Webers, 10 raised to 4 Webers, 10 raised to minus 4 Webers, 10 raised to 8 Webers. 1 Maxwell is equal to 10 raised to 8 Webers. 1 Tesla is equal to 1 Weber per square meter, 1 Weber per meter, 1 Weber per meter square, 1 Weber per 1 milliweber per meter square. 1 Tesla is equal to 1 Weber per meter square. The tubes of, here you can see that the tubes of force within this magnetic material is known as electric flux, line of force, tube of indication, none of the above. The tubes of force within the magnetic material is known as lines of force. The Boyd-Savart law is generally modification of Kirchhoff law, Lenz law, Ampere's law, and Faraday's law. The Boyd-Savart law is generally modification of Ampere's law. The magnetic material exhibit the property of magnetization because of, here you can see that the magnetic material exhibits the property of magnetization because of orbital motion of electrons, spin of electrons, spin of nucleus, all of the above. Here you can see that the magnetic material exhibits in the property of magnetism because of arbitrary motion of the electrons, spin of electrons, and spin of the nucleus. For which of the following materials our saturation value is highest? You can see that the saturation value is highest in which material? Ferromagnetic material, paramagnetic material, diamagnetic material, ferrites. You can see that ferrite has a saturation value is the highest. Which of the following materials the net magnetic movement should be zero. You can see that the then magnetic moment should be zero. In which material it should be? If the options are given that these diamagnetic materials, ferromagnetic materials, antiferromagnetic materials, and antiferromagnetic materials. You can see that the net magnetic moment should be zero in antiferromagnetic materials. A permanent magnet, here you can see that a permanent magnet attracts some substance for repulse others, attracts all the paramagnetic substance and repulse others, attracts only ferromagnetic substance, attracts ferromagnetic substance and repulse all others. Here you can see that the permanent magnet is attracts some substance and repulse others. The relative permittivity of dash material is not constant. Here you can see that the relative permittivity of dash material, which is material that is diamagnetic, paramagnetic, and ferromagnetic and insulating. Which of the material is not constant? Here you can see that this ferromagnetic material is not constant. Here you can see that these ferrites are a subgroup of. Here you can see that the ferrites are subgroup of the options given as non-magnetic materials, ferromagnetic materials, paramagnetic materials, and ferrimagnetic materials. You can see that the ferrites are the subgroup. Here you can see that there is a subgroup of, that is, ferrimagnetic materials. Here you can see that degassing is a process of removal of magnetic impurities, removal of gases from these material, remagnetizing metallic parts and demagnetizing the metal parts. Here you can just, the process is demagnetizing the metal parts. In the left hand rule, here you can see that in left hand rule the forefinger is always repeated. It is one of the important question. Lot of competitive exams, it is a repeated one. Please remember this question. The left hand rule, the forefinger is always remember, so always represents to voltage, current, magnetic field, and direction of the direction force on the conductor. Here you can see that the left hand rule, the forefinger is always represents the magnetic field. The main constituent of these permalloy, these are permalloy, is cobalt, chromium, nickel, and tungsten. It is a nickel. Which of the following is a vector quantity? Here you can, here they asked as the vector quantity for given option, which is a vector quantity. It is a relative permittivity, magnetic field intensity, and flux density, and magnetic potential. It is the magnetic field intensity is a vector quantity. Tesla is a unit of. Here you can see that the Tesla is a unit of which of the following? It is, that is the field strength, inductance, flux density, and flux. It is, the Tesla is a unit of the flux density. A magnet does not attract. Here you can see that a magnet not attracts. Which material is the magnet? A magnet does not attract. It is called cobalt, nickel, copper, and iron. That is copper. The direction of magnetic lines of force is from south pole to north pole, from north pole to south pole, from one end to another, one end of the magnet to another, and none of the above. Here you can see that the direction of magnetic lines of the force are always from north pole to south pole. Soft magnetic material, here they ask that the soft magnetic material is tungsten, steel, alchemax, bismuth, and iron. The soft magnetic material is iron. The magnetic susceptibility for a paramagnetic material is given as less than 0, less than 1, but positive, greater than 1, and equal to 1. Here you can see that the magnetic susceptibility of paramagnetic material is less than 1 but positive. You can see that less than 1, it should be less than 1 and positive. The magnetic material exhibits the property of magnetization. Here you can see that the magnetic material exhibits the property of magnetization is due to spin of nucleus, spin of electrons, orbital motion of the electrons, all the above. Here you can see that the magnetic material exhibits the property of magnetization, spin of nucleus, spin of the electrons, orbital motion of the electrons. The option is all the above. These three are the properties of the magnetization. Soft magnetic materials have, here you can see that the soft magnetic materials have high permeability, low permeability and high corrosive force, and high residual magnetism, low resistivity. Here you can see that the soft magnetic materials has high permeability and low corrosive force. Please subscribe my channel and share the video with your friends if you like this, and it will be helpful to their